3 points A, B, C have coordinates A, B and C here, those ones listed there, and it says and show that angle ABC is a right angle. So I've added a little roof here just to emphasize the fact that the angle is at B, yeah, because it's like ABC is like the angle that's created when you join A to B and then B to C. So the center letter there is the important one, and then we want to show that this is a right angle. So we're not sure yet, we've got to prove it, right? Okay, is this a right angle? So to show it's a right angle, of course, what that would mean then is the line AB would be perpendicular, okay, to BC. Okay, so that line there, okay, those letters there, AB, would be right angles to BC, okay, perpendicular. So all I need to do is work out the gradient of them. Okay, so gradient of AB. Now when you get the gradient, don't forget, use that formula, okay, that we learned from coordinate geometry. So in this case, here's my x1, y1, and that will be my x2, y2. Okay, so it'll be 10 take away 17. Be consistent then, so I did 10 take away 17, so then 15 take away 8. Okay, so on the top you get minus 7, on the bottom you get 7, so that will equal to minus 1. Do then the gradient of BC. Okay, so again we use the same formula, yeah, so y2 minus y1 over x2 minus x1. So in this case now B and C we're looking at, okay, so we'll call that x1, y1 this time and that x2, y2, so it'll be minus 7 take away 10 and minus 2 take away 15. So on the top there you get minus 17, on the bottom there you also get minus 17. So when you divide them, of course, that just comes out to be 1, okay? And then when we times them, okay, gradient AB times gradient BC, we get minus 1 times 1, okay? Those times together equals minus 1, which implies that they're perpendicular. Because when you multiply the two gradients equals to minus 1, remember that rule, m1 times m2 equals minus 1. If you get minus 1 out, then they're perpendicular. Okay, part B then, it says ABC lie on a circle. Explain why AC is the diameter of that circle. Well, if we draw a little sketch, right, this goes back to GCSE circle theorems, okay, one of the simplest circle theorems. Okay, so if we just draw a little circle here, you'll realise that if the 3 points lie on a circle and two of them join to create through the diameter. So what does this say? It says AC is the diameter. Okay. Well, you know what? It doesn't matter where B is here. Okay. B could be over here. B could be there. It doesn't matter where. B is going to be somewhere on that circle. When you connect it to A and C, even from my sketch here, okay, I've gone through the diameter. You can see that this is a right angle there. Okay. Because I've drawn it accurately, gone through the diameter there, gone through the center. So what we could say is, right, on a circle, angles created, or angle in a semicircle, triangle, is a right angle, is always. Okay, so that's just stating a fact there, that the angles in a semicircle triangle that's been created here is always a right angle. Okay, so then it says determine whether the point minus 8 minus 2 lies inside the circle, on the circle, or outside the circle. Okay, so we've got this point here now, D, minus 8 minus 2, and we've got to determine whether it's in the circle on the circle or outside the circle. Alright, so in order to do that, what I'm going to need to do is figure out what the centre of the circle is. Okay, and that's quite straightforward because we know A is 8, 17, and we know C is -2, -7. So if I get the centre there, okay, I can then work out the distance from the centre to that point D to see whether it's inside or outside. So to get the centre, it's this midpoint of AC. So basically, we'll call it M there, should be the midpoint. So M will equal to, using that formula for midpoint. So remember, you add the X values, divide by 2, add the Y values, divide by 2. So we've got 8 and -2. And we've got 17 and -7. So that comes out to be 3, 5. Okay, so this is 3, 5 here. Now, of course, we need to get the distance from M to D to see where it is. Okay, but before that, of course, we need to know what the radius of this circle is. Okay, so to get the radius, I then need to work out the distance from A to M. Yeah, so the distance A to M. Remember the distance formula now, because we've taken away there. So it'd be x2 minus x1 all squared plus y2 minus y1 all squared. So that will be, take this as x2, y2, x1, y1. So it'll be 3, take away 8 all squared, 5, take away 17 all squared. So when you work that out in your calculator, that comes out to be 13. Okay, that's the distance A to M. Now let's work out the distance from M to D. Okay, so distance of M to D. So we see then if it's less than 13, it'll be inside the circle. Okay, if it's equal to 13 exactly, it will be on the circle. If it's more, it'll be outside. So we've got -8, -3 all squared, plus then -2, -5 all squared. So I work that out. That will come out to be square root of 170. Okay. And if I put that as SD on my calculator, then it comes out as 13.03. So it's going to be slightly outside the circle, isn't it? Because the distance from the centre to D is 13.03. So it'll be outside the circle. Just about.